Hi, today we have a related rates problem in Calculus 1. And as you could see, I have the problem with colors and details with a figure on the right side to help us solve the problem. Let's get started. As you could see, I have the problem written, and I do have colors to highlight the main parts of the problem and the graph on the left. I'm trying to fit everything on one page or one slide. This way you don't have to go back after a few minutes and see what was given or what was on the graph. The way I do my videos is I try my best to clean up my notes to save you some time and have less time in recording instead of using the whiteboard. That's why I call my videos lecture videos with simplified examples. The problem says water is leaking out of an inverted conical tank at a rate of 9,000 centimeter cube per minute. So we do have water coming out with 9,000 centimeter cube per minute. The second line, it says at the same time the water is being pumped into the tank at a constant rate. Since it's unknown as a constant rate, let's call it C. So we have water coming in with a C constant rate. The third line reads the following. The tank has a height of 6 meters. This is the 6 meters. And a diameter at the top of 4 meters. That means the radius is 2 meters. That's the radius. Now this right here, they go together. And it says if the water level is rising at a rate of 20 centimeters per minute when the height of the water is 2 meters. But we're using centimeter all over. As you could see, the rate was going out of the tank as a leak 9,000 centimeter cube per minute, not meter. So we need to convert this right here to 200 centimeter. So the rate of the water level rising dH dt with respect to time when the radius or the height, let's say the height of the water is 2 meters, when the height is 200 centimeter is equal to 20 centimeter per minute. Find the rate in centimeter cube per minute at which water is being pumped into the tank. So what we need here is C equals question mark. That's the water coming into the tank. Round your answer to the nearest integer. As you can see now, we have the problem with the graph showing what's given and what's missing. We need C, which is the rate of the water going into the tank. Now, the volume of this cone is 1/3 pi r squared times the height. And we know by similar triangles, the triangles are graphed, so let's try to show them on the side. That's the large triangle, and this is a small triangle. If you don't know which triangles we're looking at, they are right triangles. Let me highlight the small one and show you which one is this. That's this triangle right here. Usually for related rates, this is what we do. We try to find a relation between the variables, connect them together. That's called substitution. So we could end up with the main formula with one variable instead of two variables. So looking at the graph, this is R and this is H. This right here is 2. I know it's meters, not centimeter, but that's fine, because we're going to end up with a ratio. We're going to have to simplify it. 200 centimeters, 600 centimeters, or 2 meters, 6 meters, same thing. Now these two triangles are similar, so we end up with the following ratio. We could write it any way we want as long as we stay consistent. That means if I go R to 2, that would be the same as this height to this 6. So I end up with R to 2 equals the height to 6. Multiplying both sides by 2, leaving R alone by itself, I end up with R equals, now when 2 shows on the right side, 2 and 6 simplifies to 1/3, so I have 1/3 H, or H over 3. Now this is useful information to use for later on. Going back to the volume was 1/3 pi R square times the height. But radius R is H over 3. That's what we found just a minute ago. If you notice right here, we have the volume is in terms of H, not in terms of H and R. That's the idea behind the common ratio, or the proportion that we built. Going back to the problem, simplifying, now H over 3 to the second will be H to the second over 9, and I do have another 3 in the way. That will give me 27. That's 27. Let's fix the 7. Pi on top, because that's a constant. Pi over 27 is a constant. And H to the second, another H, will have H to the third. Okay? Now, I have two things. We have, let's change the color. We have dV. Let's fix that. It's not a clear writing. dV dt, the derivative of the volume with respect to t, will end up with pi over 9 h to the second. 3 goes in the front, simplifies with 27, gives us a 9, times dh dt, using the chain rule. This problem, or this equation, let's call it equation number 1. We have another one. Since we have, but dV dt equals the rate of the volume with respect to time, notice that we have this rate going in and this rate going out. So this is a plus, this is a minus. That will give me the rate of change of the volume. So with that in mind, we do have C minus 9,000. So we have two ideas for dV dt. This is one of them, and this is another one. We're going to merge them together. That's called substitution. So let's call the second one number 2. Oops, let's go back. Let's call it number 2. This is number let's fix that and call it number 2. Okay, now I'm gonna do the following. I'm gonna set 2 equals to 1. This is 1 and this is 2. That says that C minus 9,000 is equal to number 1, which was pi over 9 h to the second dh dt. Now remember that we are looking for C. C is our main part right here. So we need C by itself. So I need to add 9,000 to both sides or move this to the right side. So C becomes by itself equals 9,000 plus pi over 9 h to the second dh dt. Remember that we have the following. This right here, dh dt is equal to 20 centimeter per minute when the height is 200 centimeter. So I'm going to use that right here. This right here with this. 9,000 plus pi over 9 h to the second times. H is 200. When the height is 200, dh dt is 20. Simplifying, I have 9,000 plus 800,000 divided by 9 pi. Simplifying, I have the following already written on the side to save you some time. 253 centimeter cube per minute. And that should do it. Thank you for watching. If you like this video, hit the like button and subscribe, and I'll see you next time. Thank you.